Okay, welcome back to another video on Math channel. It's your teacher Muslim here, and in this video we're going to be looking at some past HSC questions from the 2018 to the 2004 HSC papers for Maths Advanced, and we're focusing particularly on using index laws and surds. So let's have a look at the first question here. It's question 1 of the 2015 paper. What is 0.00523359 written in scientific notation correct as 4 significant figures? Well, if we look at our options, we can immediately eliminate A and C because they are actually 5 significant figures. So it has to be B or D. So let's look at this. We need a non-zero digit before we do our decimal point. Then we can write the rest. Times 10 to the power of negative because we're going backwards. I've put it here. I need to go back 1, 2, 3 times, so it'll be negative 3. And for 4 significant figures, we need 5.2, 3, and 4. So the answer is D. Right, next question. Question 1 of the 2014 paper. What is the value of pi squared on 6 correct to 3 significant figures? So I'm just going to use my calculator. Pi squared on 6 is 1.64. 3 significant figures. We know we can eliminate C and D. They're 4 significant figures. So the answer is A, 1.64. Right, question 1E of the 2008 paper. Expand and simplify. So here we've got a binomial product. We need to expand the brackets. So I'm going to use the FOIL method. Root 3 times 2 root 3 becomes 2 times 3, which is 6. Root 3 times 5 is 5 root 3. Minus 1 times 2 root 3 is minus 2 root 3. And minus 1 times 5 is minus 5. Alright, let's collect our like terms. 6 minus 5 is 1. 5 root 3 minus 2 root 3 is 3 root 3. Right. Question 1C of the 2007 paper. Rationalize the denominator of 1 over root 3 minus 1. Now for the next few questions, there's quite a number of these where we need to rationalize the denominator. So make sure that you can do these types of questions because there's a good chance that it might pop up in your exam. So in order for us to rationalize the denominator, we need to multiply it by the conjugate. So this has a binomial in the denominator. So the conjugate will be root 3 plus 1. Over root 3 plus 1, so we just changed that sign. We do that so that when we multiply these denominators, it'll give us a difference of 2 squares, and we won't have any surds in the denominators when we multiply them through. So we've got root 3 plus 1 in the top, because 1 times root 3 plus 1 is root 3 plus 1. Root 3 minus 1 times root 3 plus 1. That's our difference of 2 squares. So we can square the first term, which is 3, put a minus sign, square the second term, which is 1. So our final answer is root 3 plus 1 all over 2. Feel free to pause the video at any time and have a go with these questions yourself. Alright, question 11A of the 2018 paper. Rationalize the denominator of 3 over 3 plus root 2. So we've got 3 over 3 plus root 2. I'm going to multiply that by 3 minus root 2 over 3 minus root 2. Okay, again, I'm just changing that sign. And I'm just focusing on that denominator. So this is the conjugate. So we've got 3 lots of 3 minus root 2. I've got a difference of 2 squares here. I'm not going to write out the working out. I'm just going to immediately expand, multiply them through. 3 times 3 is 9. Put a minus sign. Root 2 times root 2 is 2. Alright, and then I'm just going to expand this numerator because I know 9 minus 7 is 2. Sorry, 9 minus 2 is 7. And that's not going to simplify. I can't simplify that 3 over 7. So I'm just going to expand it out to 9 minus 3 root 2 over 7. Okay. Question 11a of the 2017 paper. Rationalize this denominator of 2 over root 5 minus 1. So 2 over root 5 minus 1. The conjugate is root 5 plus 1 over root 5 plus 1. So that's going to give me 2 lots of root 5 plus 1 over root 5 times root 5 is 5. Put a minus sign. 1 squared is 1. So that becomes 2 over 4. Which can simplify to root 5 plus 1 all over 2. Okay. Alright. Question 11c of the 2015 paper. Express 8 over 2 plus root 7 with a rational denominator. Okay, you can see there's quite a few of these questions in past HSC exams. So we've got 8 lots of 2 minus root 7. 2 times 2 is 4. Put a minus sign. Root 7 times root 7 is 7. This is going to give me a negative 3, which I can't simplify with that 8, so I'm just going to expand the numerator to make it 16 minus 8 root 7 over negative 3. Now, if you don't like having a negative in the denominator, what we could do is change the signs, or we can factorize out a negative in the numerator. So negative 16 plus 8 root 7 all over negative 3. Sorry, negative 16. Then these minus signs will cancel out, leaving me with 8 root 7 minus 16 all over positive 3. Personally, I think if you left your answer as that, you should get the full marks. Okay, question 11a of the 2014 paper. Rationalize this denominator. So we have 1 over root 5 minus 2 times root 5 plus 2 over root 5 plus 2, giving us root 5 plus 2 over 5 squared is 5, minus sign 2 squared is 4. So we get root 5 plus 2 over 1, which is just root 5 plus 2. Alright, question 1f of the 2011 paper. Rationalize this, the denominator of this fraction. So we have got 4 over root 5 minus root 3. Going to multiply it by the conjugate, root 5 plus root 3. So we've got 4 lots of that over 5 squared. Root 5 squared is 5. Put a minus sign. Root 3 squared is 3. 5 minus 3 is 2. So I might just put a 2 there. And I know that that's going to simplify to give me just 2 lots of root 5 plus root 3, which I'm just going to expand out to root 5 plus 2 root 3. Alright, question 2 of the 2012 paper. Which of the following is equal to that fraction here? So again, we need to rationalize. So 1 over 2 root 5 minus root 3. Going to multiply it by 2 root 5 plus root 3 over 2 root 5 plus root 3. Giving me 2 root 5 plus 3 over this squared is going to equal to 4 times 5, which is 20. Put a minus sign. And this squared is going to equal to 3. So we've got 2 root 5 plus 3 over 17. So the answer is D. No, not D. Hold on, I made a mistake here. That should say root 3. So it is D. Alright, question 1b of the 2010 paper. Find integers a and b such that 1 over root 5 minus 2 is equal to a plus b root 5. So let's rationalize this denominator. That's going to give me root 5 plus 2. Root 5 squared is 5. Put a minus sign. 2 squared is 2. 2 squared is 4. So that's going to give me root 5 plus 2. Therefore, a is 2. And b is the number in front of root 5. And the number in front of root 5 is 1. Question 1d of the 2004 paper. Find integers a and b such that 3 minus root 2 all squared is equal to a minus b root 2. So this is a perfect square. So when we expand that out, we're going to get 3 squared, which is 9. This times this times this is 3 times 2 is 6. So we get minus 6 lots of root 2. Plus root 2 squared is 2. Simplify that, that's equal to 11 minus 6 root 2. Therefore, a is equal to the 11, and b is equal to the 6. Okay, don't be tempted to write minus 6 because there's already a minus sign here. If that said plus b, root 2, then you need to write b is equal to negative 6. Alright, question 9d, part 1 of the 2011 paper. This is the last one for today. Rationalize the denominator in the expression 1 over root n plus 1, where n is an integer and n is greater than or equal to 1. So when we rationalize this, multiply by the conjugate. That's going to give us root n minus root n plus 1 in the numerator. Here we've got our difference of 2 squares. Root n squared is just n, put a minus sign. Root n plus 1 squared is n plus 1, but remember we're subtracting all of that. So here we've got root n minus root n plus 1. N minus n is 0, and then we've got all of that over minus 1. Again, if you don't want to write that negative down here, a negative denominator, we can just change the signs of the numerator of every term in the numerator. So this is going to become positive root n plus 1, and this is going to become negative root n all over 1, which is just itself. Okay, I hope you found this video helpful. Okay, so we just went through a whole bunch of using index laws and surds questions from Maths Advanced past HSC questions or papers from 2018 to 2004. If you liked this video, if you found it helpful, please give it a like and subscribe. And I'll see you in the next video. Have a great day.